Hello, my name is Typhoon. Welcome to another lecture of our Auxiliary course. And in this section, we will set up our coding environment. So let's begin by installing the resources we will need to complete the exercises in this course. And in this section, you will install a text editor, download the example code and data, and then install the PostgreSQL database system as companion graphical user interface, which is pgadmin. And I will also tell you how to get help if you need it. So when you're finished, your computer will have a robust environment for you to learn how to analyze data with SQL. So now let's install the text editor firstly, which is the source data you will need to add to SQL database is typically stored in multiple text files, often in a format called comma-separated files, which is CSV, so comma-separated values. So you will learn more about CSV format in next lectures. But for now, let's make sure you have a text editor that will let you open those files without inadvertently harming the data. So common business application, word processors, and spreadsheet programs tend to introduce styles or hidden characters into files without asking. And that makes using them for the work problematic. And as data software expects data in precise formats. So for example, if you open a CSV file with Microsoft Excel, the program will automatically alter some data to make it more human readable, and it will assume, for example, that an item code of 093 is date and the format is 9 March, right? So text editors deal exclusively with the plain text with no embellishments such as formatting, and for that reason programmers use them to edit files that hold source code, data, and software configurations, all cases where you want your text to be treated as text or nothing more. So any text editor should work for this course purpose. So if you have a favorite, feel free to use it. So here I have some examples, which is open source and here free to use here, which is Notepad++. So let's get started with installing Notepad++ here. Just Notepad++, and here you will get an Notepad++ website, which is here. Click on the notepad++.org, and here you will come to download sections, download the last version of it, and here after that select your operating system, which is in this case my operating system is 64-bit. That's why I will install the 64-bit. You can also install for 32-bit, or you can install for ARM64 and so on. If you are using Linux, the default word processors will be okay for you. So here, after that, we will also install the Visual Studio Code by Microsoft. Visual Studio Code here. Oops, we click it 2 times. And here, I want this lecture to quick because we will wait. And we will see more lectures in next sections of our course. And it's a basic task. And if you have any problems with installing these softwares, you can contact me. I will answer to your questions immediately. So let's download for Windows. In this case, you can also download for Mac OS, Linux, and other operating systems. And here we are also installing the VS Code, Visual Studio Code. And here, more advanced users who prefer to work in a command line may want to use text editors, which are Vim. And if you have Linux, in most cases, Vim will come as a default. So now let's install the PostgreSQL and pgadmin. So in this lecture, we will also install both the PostgreSQL database system and a companion graphical administrative tool, which is pgadmin. And think of pgadmin as a helpful visual workspace for managing your PostgreSQL database. So its interface lets you see your database objects, manage settings, import and export data, and write queries, which is the code that retrieves data from your database. So one benefit of using PostgreSQL is that open source community has provided excellent guidelines that make it easy to get PostgreSQL up and running. So now I recommend you install the latest available version of PostgreSQL for your operations system to ensure that it's up to date on security patches and new features. So here, let's come to the first result, postgresql.org, and click on download here. So now click on download. And here, as you can see, we have several options: Linux, macOS, Windows, BSD, and Solaris. And here, in this case, our operating system is Windows. That's why we're gonna click on the Windows and install that. So here, as you can see here, PostgreSQL last version is 15, and that's what we're gonna install it. So here, download the installer. Here, and now we will install the latest version for Windows, and your download should begin in a few seconds. It's almost 300 megabytes. Since this is installing, we're gonna firstly, since this PostgreSQL is downloading, we're gonna install the Visual Studio Code. It's just a very basic task. You will see here now. Here, we can run. I accept our agreement after reading it. Next, and create a desktop icon. Next, and lastly, install. So let's see, our download is downloading here. Yeah, as you can see here, PostgreSQL 15.2.2 Windows 64-bit. And here, our Visual Studio is installing. Click on finish. Here it's opened. And now, as you can see, this is our starting screen, and here you can create a new file, open folder. So you can actually open most of the text files. So here you can also select a language from here. Here you can also select Bash, C++, and so on. Case here, SQL, as you can see, we also have the SQL option from here, which we will use that. Let's actually increase this font a little bit here to see. Let's write things here, and here. In order to increase the fonts here, you will go to Preferences and Settings. There's also several keyboard shortcuts for this. Here, keyboard shortcuts, and here you can see all of the keyboard shortcuts in Visual Studio in this page. So you can also, it's the Visual Studio works like a browser, which is makes it easy to work with. And here you can close this, come to different tabs. It just has a tab system like in the browsers here. Let's increase the font size, and as you can see, oops. Here, as you can see here, our font size is increased. So let's actually make it 22, so it will be more visible. And that's it. Yeah. So signed it installed. Now let's go to, as you can see, PostgreSQL is downloaded now. Click on open it. We can close our browser now for now. And yeah, it will open right now. Here, click on yes. Oh, because we opened it twice. Here. So we can close our Visual Studio Code. It takes some time depending on your computer's performance. It will have to open just now. Here. Yeah, let's actually open this again. And it might be some trouble with it starting. Perfect. Here we will close it. We see the logo here. Now it's disappeared. Here, perfect. Now click on next. Here, as you can see, there's a components to get a detailed description. You choose all of them. Click on next, and you can also provide a password for the super database user. In this case, I will put a password for 123. That's it. The port we're gonna use and we will listen for. You will learn all of these concepts in this course. Here, select the local to be used new database cluster. We will use default local. Next, and yeah, that's it. Next. Here, that's installing here. And I will, while waiting for this, I will stop the video and we'll continue when the installing is finished, and we'll see you later. Now it's almost installed. Now creating a new installer. It also created the database cluster, created database, and so on. Here, as you can see here, it's finished. So when the here, now we will click on next, finish, and here you can see this. So we're gonna click on, as you can see, this wizard will help you to complement your PostgreSQL and Enterprise DB Postgres plus installation, and you will select this PostgreSQL 15 and click on next. Now we will install some applications here. So now we will expand the spatial extensions menu, and select the PostGIS. PostGIS. We will search for that. PostGIS. Spatial extensions here. As you can see, we will select on check. We will check the checkbox on PostGIS here, and after that, here. You may see more than one listed here. If so, choose the newest version. In this case, we are seeing only one. So also expand the add-ons, tools, and utilities here, this. And we will select the EDB language pack, which installs support for programming languages, including Python. And here we will select the last version. And we will click through it several times. You will need to wait while the installer downloads the additional components. That's it with the extensions and plugins. Now we can click on next. Here. Next. Now it's downloading our extensions. As you can see, it's 77 megabytes almost. 77,000 kilobytes, but it's exactly 77 megabytes, which you will learn this next lectures. And here, we'll download just now. Almost done. 5, 4, 3, and done. Here, you'll click on next. Oops. Now it will also several details here. Now all the installation files have been successfully downloaded. We'll click on next. Here, click on OK. You can choose the language here. Okay. And that's it. We're gonna click on next. Next. Here, since it's installing here. Now our language pack setup wizard is installed. Click on finish. And here the computer restart your computer. Would you like to restart now? Yes. And here we are restarting our computer. And after all of this installed, and here write PSQL, and you are able to see this SQL command line, which you will learn in next lectures. See you later. The final piece of your setup puzzle is to get familiar with pgadmin, an administration and management tool for PostgreSQL. So the pgadmin software is free, but don't underestimate its performance, right? So it's a full-featured tool as powerful as Pi tools such as Microsoft's SQL Server Management Studio. So with pgadmin, you get a graphical interface where you can configure multiple aspects of your PostgreSQL server and databases. And most appropriately, for this course, you will use a SQL query tool for writing, running, and saving queries. So now let's run the... And assuming you follow the installation steps for your operation system earlier in this section, so here's how you launch the pgadmin. So you can also go to start menu, find the PostgreSQL folder here. That's actually here. You can also go to start menu, find the PostgreSQL folder here, as you can see here, and we have several applications here, which is one of them is pgadmin and SQL shell, which we will use all of this here. You can also use application stack builder to download and install new extensions and so on. So let's click on the pgadmin here, and that's it. Now, after you should see the pgadmin splash screen followed by the application opening. So if it's your first time launching pgadmin, you will also receive a prompt to set a master password, which you will see here. Let me get my pen here. So pgadmin is starting here. Yes. Might take some time depending on your computer's performance. Just start right up here. We also have pen here, which I will draw things on the screen. If there's a problem with starting, oh yeah, it's starting. Yes, you can see there's a dialog that you can read and see the status of our program. The pgadmin 4 is started, as you can see here. That's it. So that's the password screen that I would talk about. So you will enter the password here. In this case, I already set my password. In this case, my password is 123. And here, after that, click on OK. You can also reset master password from here to remove all the saved passwords. Will remove established connections to the server, and you may need to reconnect again. Yes. Here. And now this is the screen you will see. And here I will enter my password again. This is a new password, and here, that's it. This is our pgadmin. So here on Mac OS, when you launch the pgadmin the first time, the dialog might appear that displays the pgadmin for that application can't open because it's from an unidentified developer. So now you should have to right click on the icon and click open, and the next dialog should give you the option to open the application. Going forward, your Mac will remember you have granted this permission. So this is only applies if you are using Mac. In Linux you will, and in Windows you will open this program without any problems. So the pgadmin layout includes a left vertical pane here. This is a left vertical pane. Oops, here. This is a left vertical pane that displays an object browser where you can find available servers here, as you can see here, and databases, users, and other objects. Across the top of the screen is a collection of menu items, and below these are the tabs. Here are the tabs that displays various aspects of database objects and performance. So here now let's connect to our database. So PostgreSQL is a database management system, which means it's a software that allows you to define, manage, and query databases. So when you installed PostgreSQL, it created a database server, an instance of the application running on your computer. So that includes a default database called Postgres here. A database is a collection of objects that includes tables, functions, and much more. So this is where your actual data will lie here. So we use the SQL language as well as pgadmin to manage objects and data stored in the database. So in next lectures you will create your own databases on your PostgreSQL server to organize your work. For now, let's connect to the default Postgres database to explore pgadmin that we created. Remember, we created this database when we started and installed some extensions, and we also gave the passwords for this, and you will use that password. In this case, my password is 123 here, and click on OK. And that's it. So in the object browser, click on the downward pointing arrow to the left of the server node to show the default server, and depending on your operating system, the default server name could be localhost or PostgreSQL, where you and the PostgreSQL X here, in this case is 15, then this is the version number. So now expand the databases and then expand the default database PostgreSQL here. As you can see here, we have users, table spaces, login and group roles, and that's it. So if a pgadmin doesn't show a default under servers, you will need to add it. Right-click servers here, read, and server group, and here we will name it something. In this case, it's my name, Typhoon, and click on save. Here, as you can see at the bottom, we opened some new databases which has nothing in it. So, and after that, you will add create server group, register server, and so on. So now let's explore the query tool, right? So the pgadmin application includes a query tool, which where you write and execute the code. So to open the query tool in the pgadmin's object browser, first you click once on any database to highlight it here. In this case, it's Postgres. That's it. And then you will select the tools, and here you will also select the query tool. So first you need to click on some database. In this case, it's Postgres here. That's it. And now after clicking Postgres, just once, and after that you will come to tools and query tool. That's it. So you will see 3 panes here, separated by here 1, 2, 3. So these 3 panes, and you can also open the multiple tabs to connect and write queries for different databases, or just organize your code the way you would like. So to open another tab, click on database in the object browser. Here, as you can see, we have tab right now here. We can also open this. here. That's it. Tools. We can also use the PSQL tool, which you will see and we will use later. And here, as you can see here, this works like a browser here. We can navigate through that. So now let's enter the code into query editor. So here now we will download the lecture extension that I uploaded here in this lecture. You can also find this in the Udemy downloadable section of this lecture. Now I will come right down here. So here we will use, and let's actually use the basic statement here. So to execute this statement, highlight the line with here, select, and then click execute. As you can see, waiting will successfully run, and yeah, it showed us nothing. So here, this is the play button, execute here. You can also use the F5 to execute. This is a shortcut for execution. And yeah, and if you write the select version like that, you will see the version of our Postgres server. As you can see here, Postgres 15.2 compiled by Visual C++, built by 1914 64-bit. So you will learn much more about queries later in this course. But for now, all you need to know is that the query uses a PostgreSQL specific function called version to retrieve the version's information for the server. In my case, the output shows that I'm running in 15.2 version, and it provides additional specifics on the build of the software. Here, now we can also customize the pgadmin, which we will do later in this section. So see you later. In this lecture, I will show you how to customize the pgadmin. So you will select the file here. You will select preferences from the pgadmin menu opens, and here, as you can see, we are seeing a dialog where you can customize pgadmin's appearance and options. Here there are 3 you may want to visit now, which is here you will see the miscellaneous here, and as you can see here, after that you're gonna go to themes. Here, that's it. We are seeing our theme here. The refresh is required to apply theme. Above is the preview of the theme. So let's here we have standard, dark, and high contrast. So we can change it. Let's actually change to dark and refresh our pgadmin, and yeah, that's here. And here, as you can see here, our pgadmin theme is changed here. So we can also use the query tool here. Now, files, tools, query tool, and after that, here we will go to preferences. I will just open this to show you what will change after using the changing preferences. And after that, we will go to query tool here, as you can see here, and after that we will go to result grid, and this lets you set the maximum column width in a query result. In that dialog, choose the column data here, result grid, and here column name and column data. We have 2 options, tabs here, and after that we will choose the column data and enter value 300 in maximum column width here. That's it. And here, now our maximum column width is 300 characters. And to get help online on the pgadmin options, if you have something related to the program, you can ask me and I will answer you immediately. So see you in the next section. The PostgreSQL program you installed in previous lectures, the database management system. So a software package that allows you to define, manage, and query data stored in databases. A database, as I said, is a collection of objects that includes tables, functions, and much more. So when you installed PostgreSQL, it created a database server, an instance of the application running on your computer that includes the default database called PostgreSQL. As you can see here, this is our default database that we created in our installation process. So we will create a new database to use for the examples on this course rather than use the default. So we can keep objects related to the particular topic or application organized together. So this is a good practice. It helps avoid a pileup of tables in a single database that have no relation to each other, and it ensures that if your data will be used to power an application such as mobile application, then the application database will contain only relevant information. So to create a database, you just need one line of SQL code, which you can find this code on our lectures downloadable section. You can download the code here in the text format here. So now we will go to servers and we will click on object, create, or here tools. We will open the query tool here. So we'll go to databases, query tool, just one click on databases and query tool. So now we will use the code create database. I'm sorry. Here. So create database, and name this database. For example, in this case, let's actually name it Oxley. And here, so the statement creates in this case, the statement creates a database named Oxley on our server using the PostgreSQL settings. So I want to also note that the code consists of two keywords. In this case, it's create and database, followed by the name of new database. In this case, it's Oxley. So you end the statement with a semicolon here, which signals the end of the command. So you must end all PostgreSQL statements with a semicolon as part of the ANSI SQL standard. In some circumstances, your queries will work even if you omit the semicolon, but not always. So use the semicolon. Using the semicolon is a good habit to form. So now let's execute the SQL in pgadmin. So you install the graphical administrative tool pgadmin. If you didn't, go ahead and do that now. And I explained that in previous lectures. So for much of our work, you will use pgadmin to run the SQL statements you write, knowing as executing the code. Later in this course, I will show you how to run SQL statements in a terminal window using the PostgreSQL command line, using the PSQL here, PSQL here, oops, PSQL here. So, but getting starting with it easier with a graphical interface, of course. So here we will use the pgadmin to run the SQL statement that creates database. Then we will connect to the new database and create a table. So now let's run a PostgreSQL. So if you are using the Windows, installer says PostgreSQL launch every time you boot up. On macOS, you must double click PostgreSQL application in your application folder. So now let's click on this run button, or F5, and as you can see here, our database is query returned successfully. And here, if you are not seeing any database here, just right click on the databases or your server and click on refresh. And here, as you can see here, our Oxley database is come up here. So now let's click on it, and here, that's it. This is our Oxley database. So now what we're gonna do here, as you can see, we have databases here, we have Oxley and PostgreSQL inside this PostgreSQL server. So now we will open Oxley here, and now we will use the create. As you can see, there's several options we can do with this. And after that, after right clicking on Oxley, we will select the query tool. And as you can see here, our database name is changed. As you can see here, in previous here, we had something named Postgres here, which is, this is associated, that every command we type in here goes to here, Postgres. But in this case, as you can see, the name changed and it actually is Oxley. So that's it. And let's connect to database now here. So before you create a table, we also need to create a table, right? Because and we created our Oxley database firstly. You know, have database called Oxley, which you can use for the majority of the exercises in this course. In your own work, it's generally best practice to create a new database for each project to keep tables with the related data together. And before you create a table, you must ensure that the PG admin is connected to the auxiliary database, as I showed you, rather than to the default Postgres database. So we can actually close this. Don't save. Yeah, this is now we are connected to auxiliary database. That's it. So now let's, as I mentioned, tables are where data lives, and it's a relationship with are defined. So when you create a table, you assign a name to each column, sometimes referred to as a field or attribute, and it's assign each column a data type. These are the values with the columns will accept, such as text, integers, decimals, and dates. And the definition of the data type is one way SQL enforces the integrity of data. For example, a column defined as a date will accept data in only one of several standard formats, such as years and months and days, right? So if you try to enter characters not in a date format, for instance, the word apple, you will receive an error. So data stored in a table can be accessed and analyzed or queried. So with SQL statements, of course. You can sort, edit, and view data, as well as easily alter the table later if your needs change. So now let's make a table in our auxiliary database. So now we will use the create table. For this exercise, we will often discuss piece of data and teacher salaries. And here we will create a create table. Actually, if we would increase this font size a little bit, it will be awesome, so you can see more. And here, file, preferences. And here it has to somewhere here. Debugger, ADR, graphs, miscellaneous theme, user language is here, query tool, display, editor, font size, 2 maybe. It's so big. It's too big here. Maybe we will put 1.3 here. Browser, this dashboard, graphs, miscellaneous, path, query tool, and editor. 1 and 3. Perfect. Now we will create a table. We will write this code, and I will explain all of this code now in this lecture. We will create a table, and we will name this table teachers. And here we will have columns here. And now we will we will give it an ID, which is this ID is going to be data type of big serial. And we will also of course the teacher also has an first name and last name, which we will write that now. ID big serial, first name is gonna be var character, which is gonna be 25, and the last name, let's actually make it var character as well, 50. Last names might be longer in some cases. Tools, and var character is also the character type, and it's going to be 50. The school name might be even longer than last name. And we will also set a higher date that our teacher started his or her job, and what teacher has is salary. Yes, we will also add the salary, which is numeric here. That's it. And after that, we will close that, as you can see here. You can also close that right here or here, doesn't matter in some cases. And that's it. And I'll add the semicolon here. So the table definition is far from comprehensive. For example, it's missing several constraints that would ensure that the columns that must be filled do indeed have data, or that were not inadvertently entering duplicate values. So I cover constraint in detail in next lectures, but these early lectures, I'm omitting them to focus on getting you started on exploring data. So the code begins with the two SQL keywords, create and table, that together the name of teachers. The signal PostgreSQL, that the next bit of code describes a table to add to the database. Following an opening parenthesis, the statement includes a comma separated list of column names along with their data types. For style purposes, each new line of code is on its own line and indented for spaces, so verb isn't required but makes the code more readable. So each column, so you can also write this like that, and here like that. So writing the codes like that in the SQL makes it more readable. So each column name represents one discrete data element defined by a data type. So the ID column here, two is of the data type of big serial, right? So here, a special integer type that auto increments every time you add a new row table. So in first row, it's the big ID is gonna 1. In second row is gonna be 3, or in second one is gonna be 2, 3, 4, 5, 6, and so on. So we also have the first as I said, the first row receives the value of 1 in the ID column, and the second row 2, and so on. So the big serial data type and other serial types are PostgreSQL specific implementations, but most database systems have similar feature. So next we create columns for teachers' first name and last name, and for the school where they are teach. Each is of the data type varchar, a text column with a maximum length specified by the number in parentheses, in this case 25, 50, and 50. Although this is a safe assumption, you will discover over time that exceptions will always surprise you. So the teacher's hire date here, as you can see, hire date here, teacher's hire date is set to the data type date, and the salary column set to the data type of numeric. So I will cover these data types more thoroughly in next lectures, but this table shows some common examples for the data types. So the code block wraps up 6 with a closing parenthesis here. This is the 8th line of code with a closing parenthesis and a semicolon. So now that you have a sense of how SQL works, let's run this code in pgadmin. So here I will also need to delete. Oops, sorry. Yeah, delete this. That's it. Here. Yes. Now you have your code and you're connected to the database, so you can make the table using the same steps we did when we created this Oxley database. So open the pgadmin query tool, as I said, and just click on execute here. Syntax error, hire date. We have some errors with hire date, and as you can see, we don't have comma here. We will need that. And here, now let's run it again. And that's it. Query returned successfully in and milliseconds to write this here. And we will refresh the data here. And as you can see here, we have here foreign data wrappers, Oxley has we have here. And we will have schemes. And as you can see here, we have types, FTS, aggregatives, collections, and domains. And under that, there's something called tables. And as you can see here, we add our tables here. Let's actually view this. So you can also expand the teachers table node by clicking the arrow to the left like this of its name, and this reveals more details about the table, including the column names. Here other information appears as well, such as indexes, triggers, and constraints. So, but I will cover those in later lectures. And clicking on the table name and selecting the SQL menu here. Font create. As you can see, there is so much options here. So click on the table and selecting the SQL menu in pgadmin workspace will display SQL statements that will be used to recreate the teachers table. And here, congratulations, so far you built the database and added a table to it. And the next step is to add data to the table so you can write your first query. Hello, my name is Typhoon, and in this lecture of our Excel course, we will add rows into a table, and we will use also insert statement and other statements as well. So to insert some data into the table, you first need to create table statements just run in previous lectures. So firstly, we will start our SQL post or pgadmin, of course, pgadmin 4. This is the latest version of pgadmin, and here you will see our database that we created in previous lecture. And here we're going to enter our master password. In this case, my password is 123, and click on OK, and we are seeing our databases in it. So here, yeah, password, and here we have oxel.com and servers and database, as you can see, as catalogs bases, and here we create some Postgres database, and you will learn all of this. What do you mean? Oxel database. This is a previous lecture, and here publications, schemes, and beside this we have tables, and here, as you can see, we have tables here. So now we will, following the same steps you in previous lectures, you did create a database and tables, and here, so I'm gonna first fix that because I see that our contrast and saturation of the video is much high, and I will make it lower. So I think it's, yes. So in previous lectures, as I said, you did create the database and table here. So into your pgadmin query tool, as you can see here. So now we will add some values in it, right? Firstly, we're gonna go to pgadmin query tool here, and here we can go from it and truncate. We have several options that are here, and here you go to tools, and here query tool, and make sure you are using on Oxley Postgres that we just created. In Oxley here, if you click on this Postgres and click on tools, query tool, as you can see here, we are seeing different here, right? Postgres, Oxley, these are two different databases. Anything you write here will affect Oxley, anything you write here will affect Postgres. So now we will write our code, insert into teachers, and we will add the first name. As you can see here, we have columns. As you can see, we have several options here that we created. And here we have first name, and we will also inside this here we will also add the first name, last name, school, hire date, and salary. Hire date and salary. After that, we will add some information in it. So in this case, we will add into, and we will syntax here, add into values here. Now the first name in this case, Typhoon here, and the Typhoon first name, let's be Myth here, and yes, first we have first name, last name, school here. We have the alias, state, university. We have the after school we have hire date and salary, right? Alias, state, universities, hire date. Let's make it 2015, and here hire date. So we will have to write hire date, the dates in SQL in format here. So firstly, year 2015, and after that we will enter the month, so it's gonna be 09, and after that we will add the day, in this case 25. After that we have after hire that we will also have salary, and in this case we will add salary for example. We can also make it measure it yearly, monthly, weekly, whatever you want. In this case we will make it monthly. We will see it monthly, but we will just add some value in it, right? So SQL doesn't know if it's monthly or weekly, right, or yearly. So here we add 5,000, and after that let's add another with comma. Let's add comma, and after that we will add a new here parenthesis here, and we will add example. Let's make John, and here after John the surname John Smith, and here Cambridge State University. I don't know if the university is correct, but it's just a string here that we are using. So now first name, last name here. First name done, last name done. We have school done, and we also we need to just add hire date and salary. But we can also use some random name generator, right? So here we will add random name generator, random name generator, also random name surname generator, and their name generator here. So we have Tilly Sears, right? Bobby Preston. Fake identity generator. Generative here, as you can see here, we will generate. So now to run the Messias. So let's first complete a John Smith, and here we will add the hire date is going to be 2002. Here 12, and salary is going to be 59,000. And after that we will add here. So during the Messias, during here the Messias, and here 27 years old. We have Gizman online finance, employment physical characteristics, tracking numbers. As you can see here, this is actually pretty nice, right? Just created a fake identity for us. Here we will, and we will also, I think it made us the university. Here, let's go to advanced options. So make sure we make it employment finance, email, birthday, on, mother's maiden name, and so on. And physical characteristics, employment. So yes, it gave us the whatever. Here, the Messias, and here after last name we will add school, Oxford, and university, and after that we will add date, 2012 to 05 and 10. After that, we will add the salary. Salary is 15,000. Comma again, and we will also need to add, like, let's add 2 more person, and that's okay for us, enough. And here we will add Ahmed and Ahmed. This here, and after we have Istanbul University, or Istanbul Technical University, and after that we will add the hire date. Hire date is going to be 2015. And after that we will add salary, or let's make it 9,000. That's it. And after that we'll run it. The for entity for variable is okay. So now this code block inserts names and data for 1, 2, 3, 4 teachers, right? So here the PostgreSQL syntax follows the ANSI SQL standard. So after insert into, let me get my pen. So after insert into, right? After inserting the keywords is the name of the table, which in this case teachers. This is the name of the table. So, and the parentheses here, the parentheses are the columns to be filled, right? First name for the last name, school, hire date, salary. And in the next row are the values. This is values keyword and the data to insert each column in each row here. So 1, 2, 3, 4. That's it. So you need to enclose the data for each row in a set of parentheses, as we did here. And inside each set of parentheses, use a comma to separate each value, like this. And the order of the values must also match the order of the columns specified after the table name. So each row of the data ends with a comma, except the last row, as you can see here, which ends the entire statement with a semicolon. And ends with the semicolon here. So notice that the certain values that we are inserting are enclosed in a single quotes, but some are not, right? As you can see here. So that's because so some are not, but this is the standard SQL requirement, right? So text and data require quotes, right? So numbers, including integers and decimals, don't require quotes. As you can see, we didn't write the quotes here. So I will highlight this requirement as it comes up in examples. So also note that the date format we are using, a 4-digit year, is followed by the month and date, and each part is joined by a hyphen. So this is the international standard for data formats. Using it will help you avoid confusion, right? Why is the best to use format year, month, and then a day? So here we can check this website to, I think this was at 11.9. Yeah. So there's a public service announcement comic about this. So public service announcement are different ways of writing dates as numbers can lead to online confusion. That's why in 1988 ISO set a global standard numeric date format. So this is the correct way to write numeric dates, and the following formats are therefore discouraged here. This is the normal dates with words, and so on. And here we have cuts, cat here. So this was a comic about that made in evil days of internet. Here, close this. And you might be wondering about the ID column here, right? You see it? ID column, which is the first column into the table. So when you created the table, your script specified that the bigger serial data type. So as the PostgreSQL inserts each row, it automatically fills the ID column with auto-incrementing integer. Remember? Auto-incrementing integer. So here we have ID properties, definition, distinct constraints, variables, security, SQL. Updates for now, but it will update now. So now we will execute that command with F5 or clicking on this execute refresh button, and as you can see, relation teachers does not exist. Teachers, because we write it down PostgreSQL. Let's copy this. I always say that make sure you're writing on a correct database. So here we will run this, and as you can see here, query returned successfully. And here we will can view here. So you can take a also the last of the two numbers I wanna here. So the last of the two numbers are the insert keyword reports how many rows are affected inserted, and in this case, as you can see here, it's 404. So the first number, you might be wondering what this first number is an unused legacy PostgreSQL. So this is the value that is returned only to maintain wire protocol, so you can safely ignore it and you can make attention to second number, in this case 4, which means the inserted 4 rows. So you can also take a quick look at the data you just loaded into the features table using the pgadmin also. So in the object browser, locate the table and right click. So in the pop-up menu here, you will see the view edit data, and after that you will select the all rows here. Now let's come to here, teachers, inside node tables in teachers, and here we will click on right click on our table name, and after that we will use the view edit data all rows. Here, as you can see here, this is our database. It is ID big integer. As I said, it will increment one by one. We have a first names, Typhoon, John, Doreen, Ahmed, and Typhoon Smith, and we have a last names, Smith, the Messias, Yildiz, and we have schools here. And as you can see, Ilia State University, Cambridge State University, Oxford University, Istanbul Technical University as well. And we also have hire dates and salary numeric. So notice that even though you didn't insert a value for the ID column, each teacher has an ID number assigned. Also, each column either displays the data type you defined when creating the table. And in this example, varchar, character varying. So character varying actually means varchar. So character varying. So actually, let me take one here. So this character varying actually means the here. So this means var char that we defined in previous lectures when we created our tables and database. So seeing the data type in the results will help later. So when you decide how to write queries that handle different depending on its type. So you can view the data using the pgadmin interface in a few ways, but we will focus on writing the SQL handle use tasks. For me, the best part of digging into data isn't the prerequisites of gathering, loading, or cleaning the data, but when I actually get to interview the data, right? So these are the moments when I discover whether the data is a clean or dirty, so whether it's a complete, and most of all, when story and what story the data can tell. So think of interviewing the data as a process asking to interviewing a person applying for a job, right? So you want to ask questions that reveal whether the reality of their expertise matches their resume, right? So interviewing the data is exciting because you discover truth. So for example, you might find that half the respondents forgot to fill out the email. For example, here, let's open this with query here. Right click on the teachers, and after that we weigh the data, all rows here. So it might, for example, you might find that half of the respondents forgot to fill out the email, for example, filled in the questionnaire, or mayor hasn't paid property taxes for the past 5 years. Or you might learn that your data is dirty, names are spelled inconsistently, dates are incorrect, or numbers doesn't jibe with your expectations. So your findings become the part of the story. In SQL, interweaving data starts with the select keyword. So, which retrieves the rows and columns from one or more of the tables in a database. So a select statement can be a very simple, as you can see. We can't delete this because we use the select here by right clicking onto our teachers and clicking we edit data, and here first 100 rows, if you click on that, you will see limit 100. So we will use that select a lot. So now we're gonna firstly go to here, tables, and now we will click on the query tool, and as you can see, we are using on a database of PostgreSQL, which is the database we want to make the SQL statements on. So here's a basic SQL syntax here. So select from, and here we will use the teachers, and here let's click run, and here, as you can see, we are seeing some of them here, outputs here: Kathleen Rush, Janet Smith, Lee Reynolds, Samuel Cole, Samantha Bush, and here these are the salary of numeric, and so on. So this single line of code here shows the most basic form of SQL query, and the asterisk following with, actually let me get that pen, so the pen or ink, right, G-ink here. So now we will draw some things on the screen here. So now, okay, so here the asterisk on the screen, so here this wildcard, which is like standing for value, it doesn't represent anything in particular, and instead represents everything the value possibly be. So here it's a shorthand for select all columns. So if you had given a column name instead of the wildcard here, this command will select the value so on that column here. So the from keyword here, this from keyword indicates you want the query to return data from a particular table. So the semicolon after the table name tells the PostgreSQL it's the end of the query statement. So let's use this select statement with the asterisk wildcard on the teachers table you created in previous lectures. And once again, you open the pgadmin, select the analysis, our here Postgres database here. And after that, open the query tool here, and then execute the statement you are seeing here. So remember, as an alternative to typing these statements into the query tool, you can also run the code by clicking open file and navigating the place you have saved the code you downloaded from our attachment sections, right? Always do this if you see the code is truncated with here. So now we will once execute the query. The result here in query tools output page contains all the rows and columns you inserted into the teachers table in previous lectures. So these rows may not always appear in this order, but that's okay. So note that the ID column here of here, big integer, is automatically filled with sequential integers, even though you didn't explicitly insert them, right? So it's very handy. This is auto-incrementing integer acts as a unique identifier or key that not only ensures how each row in the table is unique, but also later gives us a way to connect this table to other tables in the database. So before you move on, note that you have two other ways to view all of all rows in a table using pgadmin, you can right click onto the teachers table in the object tree and choose the view width and all rows, and here you can see the same result here. So as you can see here, we can also, let's say, query a subset of columns here. So often it's more practical to limit the columns the query retrieves, and especially with a large database, so you don't have to wade through the excess information. So you can do this by naming columns separated by commas right after the select keyword here. So we don't need that for now. We will go to our here teachers that we used and executed our queries, SQL queries here. So now we will select. So firstly, I want to introduce how this select works. How we can query a subset of columns here. So now we went here, my first column, another column, super mooper column, and from our table name, in this case this is just an example here, my super table name. That's it. With that syntax, the query will retrieve all rows from just these three columns. So let's apply this to the teachers table. Perhaps in your Postgres, you want to focus on teachers' names, first names, and salaries, right? So in that case, you will select the relevant columns. So we're gonna use let's actually use the names, last names, and hire dates and salaries, right? Let's use the 4 here. So instead of doing this, we will use the select first the last name, and then first name, and then salary. So actually, before salary, let's print the hire date from teachers. That's it. Now let's run. And here, as you can see, we have last name, first name, hire date. Oops, we forgot the salaries, right? Salary. Oops, insert. Okay. Salary and teachers. Oops, from teachers. From teachers, that's it. As you can see here, last name, first name, hire date, and salary here. So although these examples are basic, they illustrate a good strategy for beginning your interview of databases. So generally, it's wise to start your analysis by checking whether your data is present and in the format you expect, right? So which is a task well suited to this select keyword. Are dates in a proper format complete with a month, date, and year, or they entered as once refutably observed as text with the month and year old? So does every row have values in all these columns, and there mysteriously no last name starting with letters beyond the M, right? So all these issues indicate potential hazards ranging from missing data to further records keeping somewhere in the workflow. So we are only working with a table of 6 rows. But when you are facing a table of thousands or even millions of rows, it's essential to get a quick read on your data quality and range of values it contains. To do this, let's dig deeper and add several SQL keywords. Data can make more sense and may reveal patterns more readily. So when it's arranged in order rather than jumbled randomly, right? So in SQL, we order the results of a query using clause containing the keywords order by followed by the name of the column or columns to sort. So applying this clause doesn't change the original table, only the result of the query here. So now we firstly select the last name, first name, and after that we also had the hire date and salary, right? And we selected this from teachers, and after teachers, before the semicolon here, or we can also delete semicolon, we can add later, we will use order by, and let's delete salary because we will use that salary here, order by salary, and the scanning here. So by default, order by source value in a scanning order, but here I sort in a descending order by adding the desk keyword. And the optional ask keyword specifies sorting in a scanning order. So now, by ordering the salary column from a highest to lowest, I can determine which teachers earn the most. And as you can see here, Reynolds earns the most. So if you want also to print the values here, see the values, you can also add the salary to select after hire date, right? Actually, instead of adding after the hire date, we can also add before the last name. So with these numbers, we can identify the top earners of our teachers, right? So we will add the salary before the last name, and here, that's it. The first earner, 65,000, 43,500, 43,500, 38,500, 36,200, 36,200. And we can also do, for example, instead of salary, we can also do, remember, we have had an ID here. So ID, and here, let's actually see the ID here. Or after, let's add ID after the hire date. And here. Here, if you are using keyword as a name, which is it's not the best practice, you will use double quotes outside the ID here. So in this case, if I write ID just regularly, it will the SQL will identify it as a query, and that's why we will use the ID with it in the double quotes. And here, and as you can see here, 6, 5, 4, 3, 2, 1. So that's because we use that in the scanning order of the ID. So firstly 6, 5, 4, 3, 2, 1. So if we delete that, and as you can see here, 1, 2, 3, 4, 5, 6 here. So the order by clause also accepts numbers instead of columns name. So with the number identifying the sort columns according to its position in the select number. So those, for example, order by tree and desk here. So you will see something different here. And instead of let's actually delete ID, we don't need that because here, as you can see here, we discarded here. So the ability to sort in our queries gives us a great flexibility in how we review and present the data. For example, we are not limited to sorting just one column. So we can also do this, for example, order by school, ascending, and hire date descending. That's it. And last name, first name. Let's actually, instead of using salary now, we just wanna print our last name and hire date. Yeah, that's it. So now, as you can see here, we have last name and hire date here. So that's it. SCDBRRS here. CDB. So this is the ending, and here, as you can see here, we have this. So in this case, we are retrieving the last names of teachers, their school, and the date they were hired. So here we also need to school here, and that's it. So and here by sorting this school column in ascending order and hire date in a descending order, we create a listing of teacher grouped by a school with the most recently hired teachers listed first. So this shows us who the newest teachers are at each school, right? As you can see here, Myers Middle School, 2005, 8, 1. This is the oldest teacher in a Myers Middle School, 2011, and this is the newest teacher on the Myers Middle School, 2011, 10, 30. And here, Reynolds Reynolds is the, let's actually print the names, right? First, so we will meet them, right? Oh, sorry. Okay. First name, and that's it. Yes. So here, Lee Reynolds is the oldest teacher of F.D. Roosevelt H.S. School, High School, and Jane Smith is the newest teacher of Roosevelt High School. So you can use order by on more than 2 columns, but you will soon reach a point of diminishing returns where the effect will be hardly noticeable. Imagine if you added columns about teachers, high big diggers, attained, and the grade leveled out and the birth date to order by class. It will be difficult to understand the various sort of directions output once, much less communicate to the others. So digesting the data happens more easily without focus answering a specific question. Therefore, a better strategy is to limit the number of columns in your query to only the most important and several queries to answer each question. So that's it with our lecture. In next lecture, we will also learn about the distinct. My name is Typhoon, and I'm waiting you next lecture of Oxley Academy. In a table, it's not unusual for a column to contain rows with duplicate values. In the teachers table, for example, school column lists the same school names multiple times because each school employs many teachers. So to understand the range of values in a column, we can use a distinct keyword as a part of the query that eliminates duplicates and shows only unique values. So use the distinct immediately after the select here. So firstly, actually, instead of here, we will use the order by school as well. And now we will use select distinct, actually select here, select here, distinct, and school here from teachers table, and order by school. That's it. And here, as you can see here, the result is this, just a 2 output. Even though 6 rows are in the table, the output shows the 2 unique school names in the school column. So this is a helpful first step toward assembling and assessing data quality. For example, if a school name is spelled more than one way, 2 spellings variations will be easy to spot and correct, especially if you sort the output. So when you're working with dates or numbers, distinct will help highlight inconsistent or broken formatting. For example, you might inherit a dataset which dates were entered in a column formatted with a text, a data type. So this is the practice that you should avoid, by the way, and this allows the dates, malformed dates to exist. So, and the distinct keywords also works on more than one column at a time. So if we add a column, so order by, so select distinct, school and salary, from teachers, order by school and salary. Here, And now the query returns here. Now the query returns each unique or distinct salary earned at each school. So the two teachers at Myers Middle School earns here $43,500. That pair is listed in just one row, and the query returns 5 rows rather than all 6 in a table. And the techniques gives us the ability to ask for each x in the table, what are the a values, right? So for each factory, what are all the chemicals it produced? For each selection district, who are all the candidates running for office? For each concert hall, who are the artists playing this month? Also, SQL offers more sophisticated techniques with aggregate functions that lets us count the sum and find minimum and maximum values. So I will cover this in detail of later lectures of our auxiliary course. So we can also filter the rows with where. Here sometimes we where keywords, so sometimes you will want to limit the rows query returns to only those in which one or more columns meet certain criteria. So using teachers as an example, you might want to find all teachers hired before a particular year, or all teachers making more than 75 or $70,000 at elementary schools. So for these tasks we use the where class. So the where class allows you to find rows that match specific value, a range of values, or multiple values based on the criteria supplied via an operator. And this is the keyword that lets us perform math, comparison, and logical operations. So you can also use criteria to exclude rows here. So now we will do some basic example here. Select the last name, and school and hire date, hire date from teachers. So, and we will use where keyword school, and now we will let's use the Myers Middle School, right? Myers Middle School. That's it. So now after that we will use the semicolon, and here that's it, as you can see here. So here I'm using the equals comparison operator to find rows that exactly match a value, but of course you can use other operators with where to customize your filter criteria. So here we have some most commonly used comparison operators. So firstly, this is the equal to. So this is actually, let's use the here. So this is the equal to, and this is the not equal to, greater than, less than, greater than or equal to, less than or equal to, and we also have between. This is the between, means within a range. So in here, like, I like, we will use the patch. So this is the case insensitive like, I like, and like is a case sensitive. And not here, not negates a condition. So now let's copy here. You can also, by the way, find that on internet, in Wikipedia. These are pretty popular comparison operators in programming. So, and I will also share these operators with you here. So now let's use the equal operator here with that. So where first name equals the call, right? Or last name. We can also use last name, where last name, and actually let's see it also first name here. So where last name equals Janet, or last name Cole, right? Cole. And here, as you can see, Samuel Cole, Myers Middle School, and 2005, August 1st. So next, we can also list all school names in the table, but exclude the AFD Roosevelt High School using the not equal operator. So remember, our not equal operator was this, and we can for not equal we can also use this. So you can choose it. And here we will. So to do that, to exclude all Roosevelt High School result from, we will use where school not equals to FD Roosevelt High School. Now here, so we excluded. Here we use the less than operator to the list teachers here, and we are here that we are only seeing the Myers Middle School on the output. So now we will do, let's actually use the less than operator to list teachers hired before January 1, 2002, or January 1 or January 2, 2000 here, using the date format here. Of course, we're going to use date format here. So where hire date is less than operator. Remember, this is the less than operator. And here, so sorry, let's actually display timer display. We can also make 100. I hope we can. Okay, perfect. Just perfect. Yeah. So now we will use where hire date is less than 2000 January. Yeah. Here. So you remember this is a month, the January, and here let's make it 20. So that's it. Run, and here, as you can see here, we just got one result because there's just only one, which is a Lee Reynolds, that hired before 2000 January 20th, right? So then we can also find the teachers who earn 43,000 or more using the less than greater than or equal operator. So now we will use the salary greater than or equal to 43,000 here, as you can see here. And let's also print the salary here. And we can also, instead of writing each one of yours, just select one teachers. As you can see here, the salary is numeric, and that's it. So we can also do, for example, 43,500, right? So if we do this, we will still get that same result. But if we just do one more, and here, as you can see, we just have one output here. So the next query uses here, let's we will use the between operator to find teachers who earn from 30,000 to 70,000, right? And also keep in mind that between is inclusive, meaning that result will include values matching the start and the end range specified. So now select our everything from teachers, and where salary between 40, actually let's make it 40,000 and 65,000. Now that's it. So now run it, and here that's it. This is our output that we get with between operator. So you also keep in mind that use caution with between, because its inclusive nature can lead to inadvertent double counting values. So for example, if you filter for values between 10 and 12 and run a second query using between 20 and 30, a row with the value of 20 will appear in both query results. So you can avoid this by using the more explicit greater than and less than operators to define ranges. For example, where salary greater than or equals to 40,000 and salary less than or equals to 65,000. So we will return to these operators through this course, because they will play a key role in helping us ferret out the data and answers we want to find. My name is Stefan, and I'm waiting you in another lecture of Oxley. So see you later. Comparison operators are fairly straightforward, but matching the operators, for example, like and I like, deserve additional explanation. So both let you find a variety of values that include characters matching a specified pattern, which is handy if you don't know exactly what you are searching for, or if you are rooting out misspelled words. So to use like and I like, you specify a pattern to match using one or both of the symbols, which is the first symbol is present sign and the second symbol, first symbol is present sign and the second symbol wildcard, matching just one character, and present sign means the matching one or more characters. So for example, if you are trying to find a baker, we will use here from teachers like B, or we can also use like a key, or we can also use acre, just underscore acre, or we can also use the bay underscore r here. So the difference is the like operator, which is a part of the ANSI SQL standard, is case sensitive. The I like operator, which is a PostgreSQL only implementation, is case insensitive. So here we'll use this explanation. So select first name from teachers, where first name like Sam and percentage character, and here this is another query here, and we will select the first name. So actually let's first run this, or actually first name, write this and then run, right? Teachers, oops, yeah, teachers, and where first name I like. We can also do right like that. I like Sam. Run this. That's it. Let's select this firstly. We'll get the same result. No. So over the years, I have gravitated toward using I like and wildcard operators, but to make sure I'm not inadvertently excluding results from searches. So particularly when vetting data. So I don't assure that whoever typed the names of people, places, or products, or other proper nouns always remembers to capitalize them. And if one of the goals of interviewing data is to understand its quality, using a case-insensitive search will help you to find variations. So in this case, let's actually delete this. Here, delete this. And here, as you can see, we are getting result, but with like, without I like, we will get nothing. That's it. So because like and dialect search for patterns, performance on a large databases can slow, so we can improve using indexes, which I will cover in next lectures. So you can also combine operators with and or here. So comparison operators become even more useful when we combine them, right? So to do this, we connect them using the logical operators and or along with, if needed, parentheses. So here we will use the select here all from teachers where school here Myers middle school and salary is less than 40,000. And we can also use another query here. So first, actually, let's run this. This is the first run. We can also do select all from teachers and where last name is call and or not and last name is Bosch. Let's write another query here. Select from teachers where school FD rules age high school, and we will use and salary less than 38,000 or salary is greater than 40,000. That's it. So we will copy this and we will export this one by one. Let's export. Let's run first this. As you can see, we got this here. So the first query here we executed uses and in the where class to find teachers who work at Myers Middle School and have a salary less than $40,000. So because we connect the two conditions using and, both must be true for a row to meet the criteria in the where class and be returned in the query result. And now let's run the second example. Yeah. Let's run the second example. And with this second example, that's it. So we are using or to search for any teacher whose last name matches Cole or Brush. So when we connect finding, when we connect conditions using or, only one of the conditions must be true for a row to meet the criteria of the where class. So now let's get to final example here. So the final example looks for teachers at Roosevelt whose salaries are either less than 38,000 or greater than 40,000. When we place the statements inside parentheses, those are evaluated as a group before being combined with other criteria. So in this case, the school name must be exactly FD Roosevelt High School, and the salary must be either less or higher than specified for a row to meet the criteria of where class. So if we use both and or in a class but don't use any parentheses, the database will evaluate the and condition first and then the or condition. So in the final example, in this example, That means we'd see a different result if we omitted parentheses. So here, the database would look for rows where the school name is ST Roosevelt and the salary is less than 38,000. That's it. As you can see here, we see ST Roosevelt and Myers Middle School here. It is important to understand data types because storing data in the appropriate format is fundamental to building usable databases and performing accurate analysis. So whenever I dig into a new database, I check the data type specified for each column in each table, right? So if I'm lucky, I can get my hands on a data dictionary, or a document that lists each column, specifies whether it's a number, character, or other type, and explains the column values. Unfortunately, many organizations don't create and maintain good documentation, so it's not unusual to hear we don't have data dictionary. So in that case, I inspect the table structures in pgadmin to learn as much as I can. So data types are a programming concept available to more than just SQL, and the concepts you will explore in the section will transfer well to additional languages you may want to learn. So in SQL database, each column in the table can hold one and only one data type, which you define in the create table statement by declaring the data type after the column name. So in this simple example here, we will create the create table Oxley Academy courses, and here we will add inside this parenthesis we will add we will have course creation date, course creation date, and here we will add date type. After that comma here, we will also add the integer, so course number or course sales or courses sold. Here we will add this integer, and here we will have also course name, right? Course name or course title is more appropriate. So course title is going to be text. That's it. So here in this simple example table, which you can review but don't need to create, so you will find columns with 3 different data types: a date, integer, and text. So in this table named Oxley Academy courses for hypothetical here, so we declare the course creation date column to hold date values by adding the date type. So similarly, we set courses sold to hold values or who hold whole numbers with the integer type declaration, and declare the course title to hold characters via text type. So these data types fall into 3 categories, which is these are the, and you will encounter the most, which is characters. These characters are any character or symbol. Numbers, these numbers include whole numbers and fractions, and we also have dates and times, which is the temporal information. So let's actually firstly let's understand the characters right now. So first let's create a table, and here, as you can see, we created our table. So we have 2 tables here, so let's actually refresh it, and as you can see, we have 2 tables here. Under that, we have Oxley Academy table, Oxley Academy courses table, and we have these here. So let's open columns. We have course title, course sold, and course creation date. So we also can use select all from Oxley Academy courses, and here we are seeing our date, integer, and text, but we don't have any values in it, which we will add. So now let's start with understanding the characters here. Let's actually open the Visual Studio Code, and we will write on that nice dark background. So here we will delete this, and now That's it. So we have character. So this character in here we will add, and so character string types are general purpose types suitable for any combination of text, numbers, and symbols. So character types include the char here. We also have varchar. So before varchar, I will explain this here. So this char, let's actually make it bigger now. So this character, this is a fixed length column where the character length is specified by n. A column set at, for example, character 10. This stores 20. This stores 10 characters per row, regardless of how many characters you have inserted. So here 25. This will store 25 characters per row. So if you insert fewer than 20 characters in any row, PostgreSQL pads the rest of that column with spaces. So this type, which is a part of the standard SQL, also can specify with longer name characters, for example, character and also keep in mind that nowadays is character n is used infrequently and is mainly a remnant of legacy computer systems. And we also have var character n here. So this is a variable length column where the maximum length is specified by n. So if you insert fewer than the maximum, PostgreSQL will not store extra spaces. So here, if let's consider that we have 5 characters here. So if we input our, if our value is going to be for example, Oxley is actually 6. So let's say make it 10, and the SQL will store here 1, 2, 3, 4, 5, 6 here, and SQL will store 4 more spaces to fill that 10 character. But in this case, Oxley will just store this and will not store extra spaces. For example, let's actually make it blue here. Oops, not here. Let's actually make it 10. So here, let's make it blue. So blue will take 4 spaces, right? Whereas the string 1, 2, 3, this is also string, keep in mind, will take 3. So in large databases, the practice saves considerable space. So this type included in a standard SQL also can be used, specified using the longer name, which is this character varying 10. This is the same. So here, Oxley. And we also have the text type. So this is a text type, writes like that. So text. So this is a variable length column of unlimited length. According to the PostgreSQL documentation, the longest possible character string you can store is about 1 gigabyte, up to 1 gigabyte, by the way. So this has of unlimited length. And the text type is not part of the SQL standard, but you will find similar implementations in other database systems, including the Microsoft SQL Server and MySQL. So in next lecture, we will create some examples with these here. So I'm waiting you in next lecture. My name is Tayfun, and waiting you in another awesome lecture of Oxley Academy. To see these 3 character types in action, we will code some script here. So firstly, we will create the table, and let's name it character data types, right? So create table and name it character data types, character data types. And here we will add character. I will explain all of this. Column character is going to be 10. And var character, or after that is comma. So var character column is going to be var character type, also 10. And we will also add text. So text column is going to be text. Just a text here. And we will not define size because as we told, as you learned in previous lecture, that variable length column of text is has unlimited length. So that's why we didn't wrote anything onto this. And here we will use, after that we will insert here, insert into insert into char data types and values. Insert into values of ABC, for example. That's it, ABC. And after that we will also enter ABC again, and ABC again. Yeah. And that's actually G-Ink. Start my pen. G-Ink here. And here we will also, after that we will add a comma, and after that we will also add the DFG. DAFG def DHI. We'll copy that. Here again. That's it. That's it here, and we will copy character data types to, and we will set the directory here. In this case, we can also set our directory into the desktop, I guess. Yeah, we can use the desktop. Here we will, oops. Instead of this, we can also go to this and users auxiliary, and after that we will add desktop here. That's it, and copy this to our desktop. And after that, so of course we need to write this in quotes like this because of the stick. And here we will add with format CSV header, and we will also add the limiter. The limiter is going to be this pipe. That's it. So here we define 3 character columns in this. Here, actually, let's make it later here to see more. Yes, perfect, right? And open the pen also. G-Ink, perfect. So here we define 3 character columns here. And this we defined 3 character columns of different types and insert 2 rows of the same string into each here. After that, that's it. And unlike the insert into statement you learned in previous lectures, here we are not specifying the names of the columns. So if the value statements match the number of the columns in the table, the database will assume you are inserting the values in order the column definitions here. So in this case, the ABC, first ABC goes to the character column, the second it goes to varchar, and the third goes to text here. So next we use the PostgreSQL copy keyword to export the data to a text file named desk. Oops, we didn't actually use the text file here. So my new lecture .text file, and here we will add. So we are exporting to the data to a text file named my new lecture in a directory of desktop here. And you will need to replace your directory with the full path to the directory on your computer where you want to save that file. And the examples in this course use the Windows formats, which is use a backslash between the folders and file names, and the path directory on the C drive. So if you are using Linux, you should write something like this. For example, home auxiliary desktop and my text file.txt, like this. In this case we are on Windows, so that's why we write it the backslash and C disk here. So Windows user must set permissions for the destination folder according here. And now let's run this here, and as you can see here we got an error because of the syntax at an or near here So that's because of the we need to use this parentheses instead of this. That's it. And we also have syntax error. Of course, we don't need that. Insert into character, syntax error at once. So could not open the file, permission denied. That's error that I wanted to show you here. So now we're gonna fix that error why our permission is denied now. And here, as you can see here, we got this error here. So in order to fix that, you will go to your the destination folder. In this case, it's desktop, my new lecture. And here we will right click on that, click on properties, and click on security. And here we will use edit, add, and here we will write everyone. Click on OK. And here you will have these options here. So you will allow the modify and click on apply. In this case, this might ask some questions here. Just click on continue again. 4 or 5 times it might ask you. Yeah. That's it. Here now our error will be fixed now, and click on this. As you can see here, we got successfully returned from our query. So now we're gonna go to, as you can see, our file is here, right? So click on that, and as you can see here, we are brought to that here. So in PostgreSQL here, I will also explain this. Let's actually open with the Visual Studio. No, Visual Studio Code. Here we will right click on that, open with the Visual Studio Code. That's it. So in PostgreSQL, the copy table from here, the copy table name, copy char data types 2, and copy from is the import function, and the copy table name character types 2 is the export function. So I will cover them in depth in next lectures. For now, all you need to know that is that here we have character table insert into copy to here and with here. So you will also make sure that. So this with keyword options will format the data in the file with each column separated by this pipe character. So that way you can easily see where spaces fill out the unused part of the char column. So to see the output, you open the our my new lecture.txt or whatever your file name in that case. So here, as you can see here, 1 2 3 4 5 6 7 8 9 10. We have 10 characters and almost 1 2 3 4 spaces, and here we have 10 characters as well, and here we have 7 spaces. So even though you specified 10 characters for both of the char character and var character columns, only the char columns outputs 10 characters in both rows here. You can see here. So padding unused characters with spaces, as you can see here, but in other cases there is no such practice, right? So again, there's no real performance difference among the 3 types, although this example shows the character char can potentially consume more storage. This can potentially consume more storage than other characters here. So then actually that's not needed in most cases. So if few unused spaces in each column might seem negligible, but multiplying that over millions of rows in dozens of tables, and you will soon wish you had the more economical. So I need I tend to use text on all my character columns. This text here. That saves me from having to configure maximum lengths for multiple var character columns, and means I won't need to modify a table later if the requirements for a character column change. number columns hold various types of, you guessed it, numbers, but that's not at all. So they also allow you to perform calculations on these numbers, and that's an important distinction from numbers you store as strings in a character column, which can't be added, multiplied, divided, or perform any other mathematical operations. Also, numbers stored as characters sort differently than numbers stored as numbers. So if you are doing math or the numeric order is important, you use number types. And the SQL number types includes the integers. Here, actually, let me go to here. So SQL number types includes the integers, which these are the whole numbers, both positive and the negative. In this case, for example, 12, and here this is also number, here number, here number, and so on. And we also have the fixed point and floating numbers. So floating numbers. So this is the floating point number. So these are the two formats of fractions, the full numbers here. And we will look at each type separately. So we will use integers firstly. So the integer types are the most common number types you will find when exploring the SQL database. So these are the whole numbers, both positive and negative, including 0. And think of all the places integers appear in life: your street or apartment number, the serial number on your refrigerator, the number on a raffle ticket. And the SQL standard provides 3 integer types, which is the small int or integer types here, which these are the small int, integer, and big integer, big int. And the difference between these types is the maximum size of numbers they can hold. And here I will write that. So small integer is the data type that storage size is 2 bytes. 2 bytes, and which the range is from minus negative 32,768 to plus positive 32,767. And we also have integer, which holds 4 bytes of data, and which these are the this number is pretty big. But it's nothing compared to big integer. So it holds it's from 214 and 7, 214, 748, 3648 here. As you can see here, we can hold 2,148,483,648 numbers from this number to this. Just copy this to this. Just 7, 36, 47. And we also have big integer. And guess what the storage size of this big integer is? Big integer. So I'm waiting for you. Yeah, it's 8 bytes. 8 bytes. And here this is the 92233720368 for 547758 and 08 from this number to this. Just 7 instead minus 1 here. So the big integer type will cover just about any requirement you will ever have with a number column, though it eats up the most storage. So its use is a must if you are working with a number larger than 2.1 billion. But you also can easily make it your go-to default and never worry about not being able to fit a number in the column. And on the other hand, if you are confident numbers will remain within the integer limit, that type is a good choice because it doesn't consume as much space as big integer. And this is a concern when dealing with millions of data rows. And when you know that values will remain constrained, small integer makes sense. So days of the months or years are good examples. Then the small int type will use half the storage as integer, so it's smart database design choice and the design decision if the column values will always fit within this range. So if you try to insert a number into any of these columns that is outside its range, the database will stop the operation and return an out of range error. Sometimes it's helpful to create a column that holds integers that auto-increment each time you add a row onto the table. For example, you might use an auto-incrementing column to create an unique ID number, also known as a primary key, for each row in the table. And each row then has its own ID that other tables in the database can reference, and a concept I will cover in next lectures. And with PostgreSQL, you have two ways to auto-increment an integer column. One is the serial data type and a PostgreSQL specific implementation of the ANSI SQL standard for auto-numbered identity columns, and the other is ANSI SQL standard identity keyword. So let's start with a serial. So now you will learn auto-incrementing with serial here. So in previous lecture, you made a teachers table. Let me actually show that to you. We added data, our rows. So you made a teachers table. You created an ID column with the ID column with, oops, sorry. Here. So you created the ID column with the declaration of big serial. Big integer, big serial is. So this is its sibling. Small serial and serial are not much true data types. A special implementation of the corresponding small integer, integer, and big integer types. So when you add a column with a serial type, PostgreSQL will auto-increment the value each time you insert a row, starting with 1, of course. So up to the maximum of each integer. So here, instead of small serial, we will have the same here, same types, and instead of integer, but we will change its name to serial data type. Serial data types, and we will have, instead of small integer, integer, and big integer, we will have small serial, serial, and big serial, So here we have small serial, we'll have small serial name, and it will have something like from 1 to 32,767. And for serial, we will have from 1 to this number. And for big serial, we will have from this number, from 1 to this number here. So to use a serial type on a column, declare in the create table statement as you would an integer type. So here, for example, you could create a table called, let's actually use the query table. Let's actually create a new table and query tool. So here we will create some new table, and we will name it, let's name it the auxiliary students, right? So here, create table, auxiliary students, and here we will add ID serial or student number, it's gonna be serial, and we will also have student name or student email, it's gonna be text here, and we will also have the or instead of text, we can also use the student email as a var character. We make it 100. Yeah, that's it for now. And here, let's execute this. And as you can see, query returned successfully in 75 seconds. If your table is not appeared here, you can use the here, right click on the tables, click on refresh, and here, as you can see here, we have the auxiliary students, and we have columns here, student number and student email. So every time a new row with the person name is added to the table, ID column will increment by 1. So we can also do, for example, as a version of 10, PostgreSQL includes support for identity. This is the standard SQL implementation for auto-incrementing integers. And the identity syntax is more verbose here, but some databases users prefer it for its cross-compatibility with other database systems, such as Oracle, and also because it has an option to prevent users from accidentally inserting values into auto-incrementing column, which serial types will permit. So you can specify identity in 2 ways. The first is generated always as identity, generated like this, generated always as identity. This identity. So this tells the database to always fill the column with an auto-incremented value, and the user cannot insert a value into the ID column without manually overriding that setting. So you see the overriding system values section of the PostgreSQL insert documentation at the SQL insert link here. And we can also generate it by default here. So generate default as identity tells the database to fill the column with an auto-incremented value by default if the user does not deploy one. So this option allows for the possibility of duplicate values, which can make use of it problematic for creating key columns. And I will delve into that more in next lectures. So for now, we will stick with the first option. You will use always to create a table called auxiliary students that has an ID column populated with identity. So you will first let's actually delete the auxiliary students data table, and here, as you can see, we have truncate here, delete drop here. Let's drop here. That's it. So now right click on the tables, click on the query tool. We will write new query here. So now we will do create table auxiliary students, and we will use ID integer and generate here we will generated always generated always as identity. After that, we will use the email, right? So, and email is gonna be the var character and the 100 limit. That's it. So for the ID data type, we use integer followed by the keywords generated always as identity. Now every time we insert a person name value into the table, the database will fill the ID column with an auto-incremented value. So given its compatibility with ANSI SQL standard, I will use identity for the remainder of this course. So even though the value is an auto-incrementing column increases each time a row is added, some scenarios will create gaps in the sequence of numbers in the column. If row is deleted, for example, the value in that row is never replaced. So if a row insert is aborted, the sequence for the column will still be incremented. Decimals represent a whole number plus a fraction of a whole number, and the fraction is represented by digits following a decimal point. in SQL database, they are handled by a fixed point and floating point data types. For example, the distance from my house to the nearest grocery is 7.5 kilometers or miles. So I could insert 7.5 kilometers into either a fixed point or floating point column with no complete from PostgreSQL, and the only difference is how the computer stores the data. In a moment, you will see that has important implications. So let's first understand the fixed point number. So the fixed point type, also called arbitrary precision, is a numeric precision and scale. And so you give the argument precision as the maximum number of digits to the left and the right of the decimal point, and you give the argument scale as the number of digits allowable on the right of the decimal point. Alternatively, you can specify this type using the decimal precision scale. Both are the part of the ANSI SQL standard. So if you omit specifying a scale value, the scale will be set to 0. In effect, that creates an integer. So if you omit specifying the precision and the scale, the database will store values of any precision and scale up the maximum allowed. That's up to 131,072 digits before the decimal point and 60,383 digits after the decimal point. So, for example, let's say you are collecting rainfall totals from the several local airports, not an unlikely data analysis task, but the US National Weather Service provides this data with a rainfall typically measured to 2 decimal places. And if you are like me, you have a distant memory of your primary school math teacher explaining that 2 digits after a decimal is the hundredths place. So to record rainfall in the database using a 5 digits total, the precision, and 2 digits maximum to the right of the decimal, the scale, you'd specify it 5, decimal 5, and or instead of we can also numeric 5, and we will use 2, right? The database will always return 2 digits to the right of the decimal point, even if you don't enter a number that contains 2 digits, such as 1.53 or 1.00, it's just 1.00, and 121.50, right? So, and let's understand the floating point now. So the floating point types are real and double. So let's actually make it this fixed point numbers. So here we will have, for example, so I will share this text for you. And we also have, as I said, floating point numbers. The floating point, actually there are the 2 floating point types, are real and double precision. So floating point or floating point types. So there's a 2, as I said, there's a real and a double precision. So both part of the SQL standard. So the difference between the 2 is how much data they store. So the real type allows precision to 6 decimal digits and the double precision to 15 decimal digits of precision. So both of which include the numbers of digits on both sides of the point. So these floating point types are also called variable precision types. So the database stores the number in parts representing the digits and an exponent and the location where the decimal point belongs. So unlike numeric, where we specify fixed precision and scale, the decimal point in a given column can float depending on the number. So let's actually use some examples with that. And double precision. So we have each type has differing limits on the number of total digits or precision. So it can hold like this. So fixed point and floating point data numbers. So we have a data type 5, 1, 2, 4, and here we have storage size 1, 2, 3, 4, or actual storage size can be more. Yeah, storage size is okay. And we will also have the storage type, lastly the range. So in data type we have, for example, numeric range, numeric and decimal, numeric decimal. For decimal we have a storage size of variable, right? Variable, and this is then variable, and storage type is fixed point, and up to 131,072 digits before the decimal point, and up to before decimal, and up to 16,383 after the after decimal point. That's it. And we also have the real. This is the database real. So this has 4 bytes, and we have here and the storage type we have the floating point, and in range we have 6 decimal digits precision, and we also have the double precision. So these are actually not separate types, these are actually same types. Double precision, these writes together precision. And we have 8 bytes, and this is the, of course, floating point again, and it holds it holds 15 decimal digits. 15 decimal digits precision. So to see how each of the 3 data types handles the same numbers, we will create a small number and insert a variety of test cases. So now we will firstly, let's actually go to here and write our code. So first we'll create a table, and we will name it number data types, and open the squares here, braces, and here we will numeric column, and we will add numeric, and 20 and 5. Yeah. And after that we will add real column, and we will make it real type, and we will also add double column, and this is gonna we will name it double precision. That's it. And after that we will insert some numbers in it. So insert into number data types, and we will enter the values. Here we will have 0.7, 0.7, and 0.7 again. And after that we will enter another numbers as well. So, and we will enter the same numbers to see how the output is differentiates from each other. So in this case we will enter 5.98, 23, and 14. Let's copy this, and we will paste again and again. And after that we will write much longer. In this case, for example, let's actually, we can delete one, and to make sure that has 5 numbers in it. Let's delete the 4 in all of the cases. And now we will add much larger number. So here we will add 10, right? Let's make it 10, a floating point. So 1, 2, 3, 4, and 5. That's it. And after that, we will see our tables. Select from number data types. That's it. Let's run. Oops. Yes, we don't need that for now. Yeah. And also we have an error here. That's it. So we create a table with one column for each of the fractional data types. And here with this, and load 3 rows into the table. And with this code, with this query here. So each row repeats the same number across all 3 columns. With when the last line of the script runs and we select everything from the table, we get this following here. Here. We get this following. So notice what happened, right? So the numeric column set with a scale of a 5. And stores 5 digits after the decimal point, whether or not you inserted that many. So if fewer than 5, it pads the rest with zeros. You see here, we have 0.0, 0.7, we have, and lots of zeros here. So, and as with third row number with 10 digits after the decimal, right? So the real number, the real and double precision columns add no padding, as you can see here. Real and double precision add no padding. On the third row, you can see the PostgreSQL default behavior in those 2 columns, which is the output floating point numbers using their shortest precise decimal representation rather than show the entire values you see here. So note that the older versions of PostgreSQL may display slightly different result. So you can also run trouble with the floating point math. So here we will multiply, right? Actually, we can also. So if you're thinking, well, a number stored as a floating point look just like a number stored as fixed, right? Straight casually, the way computers store floating point numbers can lead to unintended mathematical errors. So look at what happens when we do some calculations on these numbers here. So now, after that, we will run the script again. As you can see, we will get an error because it already exists. So for now, we will just delete that one. And I will also copy this somewhere. So I will share this code with you. So now we will select numeric column. And here we will write, let's actually write 1, 2, 3, 4, 5, 6, 7, 8. Or maybe, yeah. 1, 2, 3, 4, 5, 6, 7, 8. And we will make it, let's actually make it as fixed, right? As fixed. And after that, real column, again, this here, as floating. And from number data types, where numeric column, you will get an error now. 7. So let's run this, and here the column error does not, numeric column does not exist. Okay, let me actually refresh it. Numeric, oh sorry, numeric. Instead of numeric, I just wrote the character mistake and I wrote numeric here. as you can see here, we got this here. So here we multiply the numeric column and the real column by 10 million and use a where clause to filter out the just first row. So we should get the same result for both calculations, right? So here's what the query returns here. Hello, no wonder floating point types are referred to as inexact. So it's a good thing. I'm not using this math to launch a mission to Mars or recalculate the federal budget deficit. So the reason floating point math produce such errors is that the computer attempts to squeeze lots of information into finite number of bits. So the topic is the subject of a lot of writings, and it's beyond the scope of this course, but however we will touch this topic in next lectures. So the storage required by the numeric data type is variable, and depending on the precision and the scale specified, numeric can consume considerable more space than the floating point types. If you are working with millions of rows, it's worth considering whether you can live with the relatively inexact floating point mathematicals. So now, at the last topic of this lecture, we will choose our number data type. So for now, here are 3 guidelines to consider when you are dealing with numeric data types. So use integers when possible, unless your data uses decimals, and stick with integer types mostly. So if you're working with a decimal data and need calculations to be exact, for example, dealing with money, for example, choose numeric or its equivalent decimal. Float types will save space, but the inexactness of floating point math won't pass muster in many applications. So use them only when exactness is not as important. So choose a big enough number type unless you are designing a database to hold millions of rows on the side of the bigger. So when you're using a numeric or decimal, set the precision large enough to accommodate the number of digits on both sides of the decimal point. So with the whole numbers, use big integer unless you're absolutely sure long values will be constrained to fit into the smaller integer or small integer type. Whenever you enter a date into a search form, you are reaping the benefit of the databases having an awareness of the current time and received from the server, plus the ability to handle formats for dates, times, and nuances of the calendar, such as leap years and time zones. So this is essential for storytelling with data, because the usually when something occurred is usually available as question as who, what, or how many were involved. So here we have 4 types of data and times here. So I will open this. So like this here. So we have data and time data types. So here we have, firstly, of course, we will need to make some here. We have a data type here, and after that we will have storage size, and after that we will description. After that we will add range. So here, firstly, we would have timestamp. The storage size of timestamp is 8 bytes. And description is date, and type. Yeah, date and time. Here, and let's make it range here. So that's it. And the ranges 4,713 here, and BC, and from this here 2942 and 76 AD here, AD, that's it. And we also have date, and in date we have storage size of 4 bytes, and here we have only date but no time, and the range start same BC to, like, it has more AD than timestamp. So it's 5874 897 AD. And here we also have time, which is 8 bytes. 8 bytes. And the time only stores time and no date. The time starts from 0, 0, 0. And also it counts seconds to 24, 0, 0, 0, 0 here. And we also have interval, lastly, interval. This is here. This is 16 bytes. And here we have just had time interval. And it starts plus or minus here. 118, 0, 0, 0, 0, 0, 0, 180, 178 million years. That's it. So now the timestamp here, timestamp, let's actually make it like that. The timestamp records date and time, which are useful for a range of situations. You might track departures and arrivals of passenger flights, a schedule of Major League Baseball games, football games, or incidents along a timeline. So you will always, almost always want to add the keywords with time zone to ensure that the time recorded for an event includes the time zone where it occurred. Otherwise, times recorded in the various places around the globe become impossible to compare. So the format timestamp with time zone is a part of the SQL standard. With PostgreSQL, you can specify the same data type using the time stamps. Here. And we also have date here. This records just a date, and this is a part of the SQL standard. We have also time here. The time records just a time, and is a part of the SQL standard, although you can add with time zone keywords. Without a date, the time zone will be meaningless. And here we have also interval. So interval holds a value representing a unit of time expressed in the format quantity unit, and it doesn't record the start or end of the time period, only its length. So examples include, for example, 12 days or 8 hours. And here you can also find the PostgreSQL documentation lists unit values ranging from microseconds to millennium. So now let's go to writing our codes here, right? So we also had some code that I will share you as an attachment, but it has nothing to do with our today's lectures. So we will create a new table. That's why we're gonna go to here. As you can see, we have tables. Right click on this, create a table. No, of course we're gonna use the query tool as well. We will create SQL queries. So create table and date. I will explain all of these codes here. Date, time, types, and here we will have timestamp. Also, let's actually, yeah, timestamp column and timestamp with time zone. Here, after that, we will add interval column. That's it. And here we will also add another code here, which is insert. We will insert into date time types, and this we're gonna have some values in it. Values, which is these values include 2023, the month, and then day. Here after that we will add hours. Here EST, and after that we will add here 2 days. We'll add another value in it. So here we will add same date, 2023, January or December here, 31, and here 01, 00, -8, and after that we will make it 1 month. After that we will add a comma here, we will add another 2023, 12, 31, 01 here, and we will add let's actually add some Australia, right? So Australia Melbourne. So here we will add, after that we will do it 1 century, and after that we will list all of the information that we wrote here, which is using the select asterisk from date time types here. And here we create a table with a column for both types, and here, and we insert the for also we also need to insert another row here, which is, it's going to be now. You will see what this magic does, what this function does, and it's going to be 1 week. So that's it. So here we first create a column for both types, timestamp with time zone and interval, and after that I insert our 4 rows. So for the first 3 rows, our insert for the timestamp column uses the same date and time, December 31, December, yeah. It's December 31, 2023. And at 1 a.m., and using the International Organization for Standardization, ISO, format for the dates and times, firstly we got years, months, and days. And also we have hours, minutes, and seconds. In this case, we didn't add any seconds here. So SQL supports additional date formats such as months, days, years, but ISO is recommended for portability worldwide. So following the time, we specify a time zone, but use a different format in each of the first 3 rows. So in the first row, we use the abbreviation STR, which is a Eastern Standard Time in the United States. In the second row, we set the time zone with the value -8. That represents the number of hours difference or offset from the Coordinated Universal Time, UTC. And the time standard for the world, the value UTC, is ±0 hours and 0 minutes. So -8 specifies a time zone 8 hours behind UTC. So in the United States, when daylight saving time is in effect, -8 is the value for the Alaska time zone. So from November through the early March, when the United States reverts to a standard time, it refers to the Pacific time zone. So for the third row here, we specify the time zone using the name of an area and location, which is Australia, Melbourne. So that format uses values found in standard time zone database often employed in computer programming. You can learn this more from here in Wikipedia TZ database, and here you will see time zones. As you can see here, America, Asia, Makassar, Manila, Muscat, Nicosia, and so on. And here we also have the UTC offset, STD, DST, and time zone abbreviation. That's it. And let's run the script now. Duration data time does not exist. So because, yes. Create data date. Oh, not data, date time. That's it. As you can see here, This is our output. Even though we supplied the same date and time in the first 3 rows on the timestamp column, as you can see here, the rows output differentiates, right? So the reason is that pgAdmin reports the date and time relative to my time zone, which is the result shown is indicated by the UTC offset of -5. You see here, -5 ECT, -5, and Australia Melbourne. So at the end of each time step, of course. So a UTC offset of -0.5 means 5 hours behind UTC, equivalent to the US Eastern time zone during fall and winter months when standard time is observed. So if you live in different time zone, you will likely to see a different offset, and the times and dates also may differ from what's shown here. So we can change how PostgreSQL reports the timestamp values, and I will cover how to do that, plus other tips for wrangling dates and times in next lectures. And finally, the interval column shows the value you entered, and PostgreSQL changed 1 century to 100 years here, and 1 week to 7 days because of its preferred default setting for interval display. And you can also read the interval input section of the PostgreSQL documentation on their official website to learn more about these interval inputs here. So I'm waiting you in next lecture. The interval data type is useful for easy to understand calculations on date and time data. For example, let's say you have a column that holds the date a client signed a contract. So using interval data, you can add 90 days to each contract date to determine when to follow up with the client. So to see how interval data type works, we will use date time types table that we have just created. Let's actually here date time types table that we just created. Column interval, we have just 2 columns, interval column and timestamp column and interval column. And here we have we will write select timestamp column and interval column, and after that we will add timestamp column minus negative here interval column. Actually, let's go to a new line. So interval column, and after that we will add timestamp column minus interval column as new date from date time types. That's it. Let's run it. We have a timestamp here. So this is a typical select statement, except we will compute a column called new date here that contains result of timestamp columns minus interval column. And computed columns are called expressions, and we will use this technique often. So in each row, we subtract the unit of time indicated by the interval data type from the date. So this produces the result here, as you can see here. So also keep in mind that new date column by default is formatted as a timestamp with time zone, allowing for the display of time values as well as the dates if the interval values uses them. You can see the data type listed in the pgAdmin results grid listed beneath the column names here. Again, your output may be different based on your time zone.